Welcome back to a lecture series on hydrogeology. In this lecture, we are now going to discuss about the Piper diagram. A Piper diagram is a diamond. A Piper diagram is a graphical interpretation of water quality data diagram, which was developed way back long. And then this is helpful for assessing the water type, the origin of the water, and its the nature of water in terms of the distribution with respect to both. You have been in this diagram. We are going to use both cation concentration and anion concentration. We are now going to, after plotting cation concentration in one plot and the other plot cations. Now we can transform these two into the central diamond shape, and over there we will be able to assess the type of water. It will be easy for us to classify into 9 classes what is the type of water in our area. It was proposed by the scientist Arthur M. Piper in the year 1944. So almost all diagrams are old, but still this diagram speaks a lot of information about the interpretation of water quality. Only this is being used in most of the water quality, I mean groundwater chemistry geologists or persons. It is a graphical representation of the chemistry of water sample. Normally it allows plot multiple samples on the same. You can plot a number of samples. It is not essential for you to use only for one sample, but if you know the if you know the procedure, you will be able to plot even 100 samples here, 100 samples here, and then project. You will be able to get 100 samples over the top of diamond diagram. It is a powerful tool, yes. Everyone has accepted, because after doing this, even we ourselves have realized that very easily we can assess what type of water it is, visualizing the relative abundance of common ions in water samples. It makes easy to determine whether it is suitable for human use also, yes. So this is the diagram. The diagram is taken. There are two triangular diagram. One is cation, and the right side triangle diagram is anion. In this left side triangle diagram, we have taken calcium at one end, magnesium at the left end, and the sodium potassium at the right end. What does it mean? The calcium is taken, the left axis is 0 and the right concentration is 100. It means calcium concentration is 100 over here, calcium is 0 here. And the sodium and potassium, if you take sodium is 0 here, potassium, sodium plus potassium is 0 here, and the concentration of sodium plus potassium is 100 here. Similarly, for the magnesium, concentration 0 here, and slowly it increases on the top of it 100 here. And here, this is the plot for representing anions. Chloride is taken over here, and the 0 concentration of Cl here, and 100 concentration, 100% concentration here. And this side, it is carbonate plus bicarbonate. 0 percentage of CO3 plus HCO3 here, and the concentration is increases. At the bottom it goes, it is up of 100% here. And sulfate is taken on the right margin, right the line, right side of the diamond line. 0 on the bottom, concentration is slowly increases, and 100 over here. In every 20 units they have divided, and then they have made a small plot also. So this helps you to draw a line for taking your samples into it inside. And this 2 is projected, over which you know that again there is a diagram. This is called diamond diagram. So this is parallel to the top edge, and this is parallel to the left edge. And in between also it is drawn. and whatever the plot we are doing from our chemical analysis report, it is being projected or transformed to the top of it. So this is the diamond diagram, Piper diamond diagram. What does it mean? It carries both together and then plot it on the top, and here our interpretation is going to start. So here the top left is sulfate and chloride, right is calcium and magnesium, bottom is sodium and potassium, sodium, potassium, calcium, magnesium, right, CaMgNaK, CO3, HCO3, sulfate, chloride. So these two is anions and these two is cations. And if I have my sample result of magnesium 27, of calcium 38, so if this is my result, like sodium and potassium is 43, and for this point it is chloride 32, Cl, you see 20, 40, 32, I have to take here SO4 59, and carbonate bicarbonate maybe around 8 or 9. Now I have to take a scale and parallel to this line I have to project. I have to draw a line over the top of it, and similarly I have to take a point from here, again parallel to this line I have to draw a line in the left hand side also. The intersection is the point of interest with respect to sample 1. The sample 1 falls here. I will tell you in the next slide how this is going to be interpreted. It is a powerful tool, yes, to visualize the relative abundance of common ions in water samples. It makes easy to determine whether it is suitable for human use. Yes, it is true. Piper plot is comprised 3 component: lower left component, lower right component, middle 2 ternary diagram. This is called diamond plot, right? Let us see. A ternary diagram in the left, lower left represent cations, that is calcium CaMgNaK, cations CaMgNaK. A ternary diagram in the lower right representing anions Cl, SO4, CO3, HCO3, Cl, CO3, HCO3 and SO4. And a diamond plot in the middle, which is a matrix transformation of 2 ternary diagrams. This is one ternary diagram and this is second ternary diagram. The diamond plot in the middle, which takes from the left to the top and right to the top, and then where you have your mixing point. Each sample is normalized. That is, sum of cations 100 and sum of anions 100. Now we have taken sum of cations and anions. So the relative concentration are on a percentage basis on the diagram, diamond diagram, right? The diamond is a matrix transformation. You are now bringing your left ternary to the right ternary on the top of it, of a graph of the anions, right, you see. And here you have sulfate plus chloride, total anions, sulfate plus chloride, carbonate bicarbonate, so this is total anions, sodium, potassium, calcium, magnesium, total anions, and cations, sodium, potassium to the total cation, sodium, potassium to the total cations, sulfate, chloride, anions, sodium, potassium, total cations. A diamond plot can then be analyzed to identify the type of water. Samples on the top quadrant, again this is being divided as one quadrant of taking 50% of sodium chloride concentration and 50% of calcium magnesium concentration, and then 15% of sodium potassium and 50% of carbon. You have to divide equally and then you will be able to construct the top quadrant. This is one. The top quadrant is what? The top quadrant is calcium sulfate water, calcium sulfate waters, which are typical of gypsum groundwater and mine drainage. So this were evaluated by many scientists. It is a gypsum groundwater and a mine drainage. Samples in the left quadrant, the calcium bicarbonate waters, which are interpreted as a typical of shallow fresh groundwater. Samples in the right quadrant are sodium chloride water, which are typical of marine and deep ancient groundwater, which are typical of marine and deep ancient groundwater. Samples in the bottom quadrant are sodium bicarbonate water, which are typical of deep groundwater influenced by ion exchange. So this is how the diamond diagram is in general classified, and in detail we can also go deep into it to interpret little much more. Characterization of water on the basis of Piper trilinear diagram. This is being given by A to H. H has to come here, B and H no dominant type. So this is divided into A, B, C, D, E, F, G, H. Okay. A, B, C, D, E, F, G, H. What A? From this plot we can interpret A is calcium type because calcium is 100% here. B is the center part, no dominance. And H is the center part of anions, no dominance. Actually H has to come here. C is magnesium 100%, magnesium type of water. And if your sample falls here, it is a sodium and potassium type water, no dominance. And similarly, suppose if our sample falls at here, it is bicarbonate type. If our sample falls at here, sulfate type. If our sample falls at here, it is a chloride, 100% chloride type, no dominance. So this is in general to characterize. In specific, you are now projecting or you are now transferring from the trilinear diagram, triangular diagram into tertiary diagram into a diamond diagram. Here it is classified into 9 classes. Here it is classified into 9 classes. How 9 classes? But you see, I could see only 5, 6, 7, 8, 9. How come 9? Yes, 1, 2, 3, 4 is over here. What is 1? 1 is nothing but 5 plus 9 plus 6. 5, 9, 6. So this is 1, right? This is 2, 8, 9, 7. This is 2. All this whole if you group together is 1. All this whole is if you group together it is 2, right? 3, 5, 9, 8. Suppose if I am taking all my samples falling within this, so my class is 3. If it is between this 6, 7, 9, that is called 4, 6, 9, 7. And after this 4 comes 5, 6, 7, 8 and type 9. What is 1? Suppose if my sample falls here, the sample is alkaline earth exceeds alkalis. Suppose if my sample falls here, alkalis exceed alkaline. Now these two things we will have to assess in terms of what are all the alkaline group, what are all the alkali group of major rock types. Suppose my sample falls in 3. Suppose here if my samples falls, that is weak acid exceeds strong acid. Suppose if my sample falls at here, strong acid exceeds weak acid. If my sample falls within these 5, magnesium bicarbonate type. If my sample falls here in 6, calcium chloride type. If my sample falls in 7, sodium chloride type. If my sample falls in 8, sodium bicarbonate type, and 9 is mixed type of water. So this is how the interpretation we do normally to assess the exact pinpointing the type of water. That helps us to understand that why that this water behaves like this. From this, we can take the lead to interpret from the lithological point of view to conclude the water and to suggest the remedial measures for the end user. With this, the discussion of Piper diagram is come to an end. Thank you very much.